Hey everybody, Dr. A here, and in this video we're going to be exploring an example of transverse shear stress. So let's go ahead and get started. In the given information, we're being asked to derive the formula tau max equals 1.5 V over A for a rectangular beam section subject to shear force V. So it's a pretty simple set of directions, but we need to understand what is going on here. So to do that, we're going to go ahead and sketch out a beam cross section that is rectangular. So let's say that this is our rectangular beam cross section, all right? And let's say that the base has a thickness T, and let's say that the beam height has a height of h, okay? Now, if it's a rectangular beam subject to a shear force V, we can just go ahead and put V right there. And we know that the neutral axis should go right through the middle of the beam, okay? Because it's a rectangle, so the centroid is right through the geometric center, which is at h over 2. From the base, okay? So we can go ahead and say, you know, this is y bar, and y bar, of course, is h over 2. So all of that should be pretty simple geometry, okay? So how do we derive this? Well, what we're going to do is we're going to start with our governing formula for beam shear stress. So we're going to start with tau equals VQ over IT, all right? That's what we're going to start with. Now, let's go ahead and dissect all of these pieces. Do we know some of it already? Well, we know V, right? V is V, so that's just sitting right there, okay? T is T, so we know that T is right there. We don't have a number for it because this is a derivation, but no problem, okay? What about I? Well, for a rectangular beam, we know that the moment of inertia is the base dimension times the height cubed over 12. We conveniently say BH cubed over 12, but B is this horizontal base dimension, which we're calling the thickness T right here, okay? So now I can check off that little I value. Now the question becomes, what do we do with Q? Well, we know that Q is equal to A prime Y prime bar, okay? And we saw the previous video, what does this mean, okay? Well, here's what I'm gonna do. We're gonna say that since tau max is at the neutral axis, we can consider A prime to be the area either above or below the neutral axis. Okay, let's just look at it above. Okay, let's take A prime to be this shaded area above the neutral axis. So if that's the case, if we're going to call this A prime, what is that going to be equal to? Well, in that case, we're going to say A prime is equal to T multiplied by H over 2. Okay, so we're going to say that's T times H over 2. All right. So that takes care of A prime. What about Y prime bar? Well, we know that Y prime bar is the perpendicular distance from the overall neutral axis to the centroid of A prime, okay? So if I shade this in just to remind myself, hey, that's A prime, okay? What I'm looking for is Y prime bar right here, okay? Again, that's the area from the overall neutral axis to the centroid of A prime. Now, what is that Y prime bar going to be? Well, it's not H over 2. it'll be h over 2 over 2, right? So it's going to be h over 4. So I'm going to go ahead and say y prime bar is h over 4, okay? Now what we can do is substitute all of these things together. So I can first combine these two and say, hey, okay, Q is going to be TH over 2 times H over 4, all right? And so we can combine these things to get our value of Q here, and that's going to be TH squared over 8, all right? Now we're ready to substitute that into tau from earlier. So how about, just to be organized, we're going to rewrite this. We're going to say tau is VQ over IT, all right? So V is V. That was just, you know, shown in our self-drawn figure. And then Q is going to be TH squared over 8, all divided by I. That was TH cubed over 12, all right? And then multiplied by T, right? T was just T, okay? So we can do some algebra combining here, okay? And so when we rearrange some things here, I'm going to show my algebra here in case maybe you have a similar homework problem or a question by a professor that wants you to show a lot more work. So we're going to say TH squared over 8 multiplied by 12 over TH cubed. And then, of course, you know, that's going to have 1 over T tacked in there, all right? Now, can we start canceling or combining things? Well, sure, we can cancel both of these H's with 2 of these. We can maybe go ahead and cancel this T and this T, all right? And so what do we end up being left with after we cancel some of that? Well, you still have V there, okay? And then you have times 12, and then you have divided by 8HT, okay? Now, what is 12 over 8? Well, that's just 1.5, okay? So now you have 1.5 V over HT. Well, what's HT? What's HT? We'll go back to the original figure. H, which was the total height, times T is area of your rectangle. So finally, we can say tau equals 1.5 V over A. And again, we could easily say A is HT here. And then we can, you know, our mathematics friends, we can put a little shaded in box here that says it has been shown, QED. So that is our final derived formula. If you found this video helpful, please hit like and subscribe and be on the lookout for other content like this. Thanks for watching.